Welcome, everybody. We are returning to our app build of the Apple Pie game. I am using the Develop in Swift Fundamentals Xcode 13 book from Apple. I'm using the student version of the book to do the app build because that's where the step-by-step instructions reside. We're currently on page 372. We had completed all the interface building, and I'm just going to go back a page to show you that we got through all the process of building the interface. We were able to get the program to build and run. And in fact, I'm going to do that preliminarily here. And this is kind of a good talking point too. Like whenever you're doing app building and you walk away for a while and you come back to it, it's not a bad idea to just run and build whatever it is you're doing, just so that you get, first of all, the simulator loaded back up into memory so it launches faster, to make sure that what you had was working and you remember like where you left it at, because it's a process, right? Basically what we did is we had built, and notice we're running on iPad here, not iPhone, but built the interface. So that includes the graphic, all the buttons. We did both horizontal and vertical stack views. Have a couple labels in here. All the buttons were connected up to IB outlets, and the labels also. And then we, I think, collectively connected all the buttons to one outlet rather than have a separate one for each one. And then we'll use code to differentiate which button was clicked, and then programmatically drive things. But basically you can kind of think of this as almost kind of like a Wordle kind of style game where it's going to be like word guessing. And right now all it does is basically allows us to click on the letters, and then after you click them they get grayed out so you can't use them again, right? That's all the app does right now. Right, I'm going to go ahead and stop the run, but I'm doing that, like, again, I'm saying I want a clean build point, as I start my day, so I know that at least what I have is running. And then, rather than write a bunch of code and go, hey, it's not working and why, so I know it's not my interface. Now, an important takeaway from last week is the fact that when we do start to build more complex applications, and this might not feel like one, but it is, but there's a lot going on that screen. It's small, but a lot going on in the form of controls. What you have to do typically, unlike when you're coding a regular program, is you have the concern of the user interface and what it looks like, and then you have the concern of the programmatic logic behind the scenes. But before you can apply the programmatic logic, your interface has to be in place. This is kind of not dissimilar from how we do things in web, where we often build that visual interface, like what goes on the screen first, and then we worry about creating back-end code to drive everything. But once the interface is in place, that frees us up to move forward. Of course, we can always tweak it and adjust it, and that often happens when you're doing this kind of thing. But if you have a really clear vision of what you want to create, ironically, the interface comes first. So, and I think that's a pretty big thing. Now, if you look at like both the the storyboard and the coding window and the stuff that we already have present here, we're going to be adding to this. And once again, looking at the instructions here in the book. Now I'm going to shuffle this over to the other screen, but basically we're going to start by doing exactly what this says. And what you're going to notice here is we're going to build basically a list or an array, right, of words that we're going to use in the program. Now, this is a really basic and simplistic list. And of course, once you get things working, you can easily make this a huge list, right? And because this game that we're doing is so darn Wordle like, and if you guys know what that game is, some people do, some people don't. You can imagine that the people that created Wordle, I mean, they have to like basically try to find like every 5-letter word in the universe and add it to that like list or however they're doing it. And that would be potential here too. So like you start with a basic list and then you can add a whole bunch of stuff as the game is correctly working. But I find it kind of fascinating, at least from the interface standpoint, when we look at the work that we did just to put the keyboard together. And then can you imagine like the keyboard that's on your smartphone or tablet or whatever, because this is just dealing with capital letters, right? Well, on a regular keyboard, you have to deal with upper lowercase, you have a shift key, and you have special characters, and then you have a numeric keypad and a special character keypad, and yada, 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 right? You just keep adding to that list. And, even those virtual on-screen keyboards have to be coded, and somebody has to do that work. So it gives you a little bit of an appreciation of the time, effort, thought, and capabilities that went into building that the first time, and we're sitting here mimicking it. Because the one thing that we could do, right, if you think about this, is you could use the system keyboard to play a game like this. You don't have to use the internal one. However, if we use the system keyboard, it wouldn't allow us to gray out the letters that we've already chosen. Right. So see the complexity there. Okay. Now, reading right from the book, it says, now you're set to work on the apple pie game logic, right? And the first thing that we need to do is to create a list of words for the players to guess. So at the very top of the view controller, and I'm going to maybe say above the IB outlets, they want us to define a variable called, and this is a var, list of words. And if you want, and you have access to the ebook, you could just copy in the list that's there. And I'm going to attempt to do that. Sometimes the copy and paste from, the Apple ebooks is not quite so elegant. And sometimes it is. And I'm kind of expecting here it's going to give me a bunch of artifacts, and it absolutely did. However, yeah, and you know what? Okay, so I want to take a look at this really quick, because this is something that might happen to you, right? So it's like, all right, I have some code. I can just copy it and paste it in. Great. And then there's a citation, right? And I delete it, but you know what? It's still broken. And I want to show you why it's broken. If you are able to zoom in here, let me see if I can command plus my way in, and you look at these double quotes. Notice these are what we call smart quotes. They're angled. They're not like your regular double quotes, which is straight up and down. They're on an angle, which means they're not recognized as a double quote. So this is broken. So I'm going to command Z myself out. And you know what? I'm actually going to go through the process of typing this in manually. And so you guys can use the same words if you want. I would recommend that, at least for now. But you could also type in something else. And because, we're just writing code right now, I'm just going to take the code window and make it a little larger. All right, so Buccaneer, Swift, glorious. Incandescent. Bug. And so there's our list of words. Next, we also want to add a constant. And so the constant, we use the keyword of let. And we want to call this one incorrect moves allowed. So how many times will we let them make the wrong choice before we, basically end the program? They're suggesting that we set the value between 1 and 7. I mean, I don't know how many people would be able to guess a word on the first try. I've never been able to do that in Wordle, by the way, but I have gotten words on the second try and the third try. Actually, not that unoften. It just depends on what your first guess is, right? If you're lucky and get a first guess. But we'll go with that number. We can always tweak it to make the game harder. Another thought, and I'm just giving you a thought here, like if you were coding this as a game that you would release, you might consider making this not a constant, but you might consider actually making it a variable, and then allowing the user to control the difficulty level with like a slider or a spinner or something, and just putting it out there. Right?
Nice.
And basic stuff, but yeah, totally. Right. Next thing we want to do is define the number of wins and losses. And it says the bottom label. So let's just take a look at that really quick here. I'm trying to get my little divider here. There we go. So the bottom label will display an updated count. So this one of the number of wins and losses. All right. So we want to create variables that are going to hold that information. So here we go. So I have a var for total wins, not wins, but wins. We'll set that to 0 for right now. And another var for total losses, also set to 0 for now. Okay. Next, we're being asked, so I'm now on the page of the top of page 373. It says when the application first launches, the viewed load method is called. And that's a good place they're saying here to start a new round in the game. So what we want to do is define a new method here. So we have the viewed load function that just loads up our app, but we're going to just call something by name that we haven't even created yet, like so. We're just going to call it new round. And we'll see if it offers a quick fix here, because I suspect that it does. Although it's not being very compliant with its assistance here. So like my IntelliSense is, I'm going to say failing. But so given the fact that it's not like giving me, like fixes, I don't know if you guys I'm like clicking like crazy and like nothing's happening. That's okay. So normally it will give you quick fixes, but instead I'm going to come down here and I'm going to add a function. So I'm going to call it func, and we'll call it new round based on the name that we gave above. Okay. So in other words, when the game loads, it'll just initiate a new version of the game right from the viewed load. And then, of course, by creating a function that does that, we can then subsequently have it start a new round after we finish a round, right? So we can have that capability built right in. Okay, so relative to this game, what does that all mean? It says each round begins with the selection of a new word and resetting the number of moves the player can make to incorrect moves allowed. So in other words, this will be affected, and these will be affected basically. It would be helpful to hold the state of the game inside of a game struct. So it says create a new file in your project by selecting file, new file, or command F. So I'm going to do file, new file. It will be a Swift file. Go ahead and click next. We're going to call the file game. And then you go ahead and click create. So now we have a blank file to work with. We do want to import the foundation, so that gives us all the standard library items. And then we're going to define a struct called game right inside here. So let's just get the framework in place. So we'll say struct game. Notice the capital G, curly brackets. Inside the struct, we will have a word, which is a string. And we will also have incorrect, gotta spell that right though, incorrect moves. So if you were wondering how we were keeping track, if the other thing is a constant, we're doing it here. That's kind of the point. So in other words, when we create a version of the game, it's going to draw upon the struct, which will grab a word from our list and keep track of how many moves you have left. And those are, we think of those as properties, basically, that travel with, All right, so there's the basic of the struct. Now we need to go back to the view controller and down in the new round function, and really technically this would be a method because it travels with all of it. So we're going to create a new instance of game down here. And all right, so I want to talk about this a little bit. So if you guys, I'm going to pull the book over as I do this, because there's a couple little things that they're throwing in here that I think are important. Back in the method, you can create a new instance of game. And I just want to show you this. This is not in the function. And we are going to call the variable current game, and notice its data type, right? So instead of a string or an int or a whatever, we're using a struct. And then there's also an exclamation point at the end of it, which actually has a special purpose because it basically is requiring it to be there. Is kind of maybe the simplistic way to look at it. But let's go ahead and do that. So let me get the book back over here. It always gets in the way if I don't. All right, so let's do that. So where you place that, I don't think really matters too much, right? But I'm going to put it up here because that's what makes sense to me. So I'm going to say var current game is of type game, right? And I'm throwing in the exclamation point. So that message appeared there for just a moment. And you know what? I'm going to remove that. And I don't know if it's like the lack of the exclamation point that does that. Nope. All right. Maybe it was just generating a message that would be interesting to look at. Down in the new round function, we're going to add a constant, right? And the constant is let new word equal list of words. And then we're going to use kind of a weird function here, or method actually, called remove first. So in other words, we're going to go into the list. We're going to pull the first word out of the list. We're removing it, but we're capturing it and placing it here. Why? Because that way it can't be used again, right? So if we remove it from the list, we won't be able to go back to it. Then following that command, we're going to say current game, the one we declared above, is equal to a game struct, but we have to provide it its structure. So we're going to say game. And then notice here it does a suggestion. You have to fill in the properties, which we're going to grab, by the way. Let's go wider on this so you can see all of it. And then for the word or the string, right, we're going to grab the constant from above, which is new word. And then for the incorrect moves remaining, we're going to feed in the variable that we also created above, which incorrect moves allowed. So in other words, we're grabbing the 7 and we're throwing it in this other variable inside the game struct, and then the game struct will decrease that. Some of my thought that I had before about allowing this to be a variable up here that we can, set the difficulty level with, and I guess you could still in principle do that, is really being monitored down here with this variable.
But I have a question.
Sure.
How come when we we created that variable new word, how come that doesn't highlight as like a color like how incorrect moves remaining does?
That's a really good question.
Is that because it's like a local scope variable? And highlight would be global?
that might be the case, but I mean, that is a really good point, Jonathan. I'm not really sure why. In principle it should. And sometimes I'm like, maybe if I scroll enough, it'll color or something. But you can see it's not doing it.
Yeah, it's not lit up for me on my screen either.
Yeah, and I'm not really sure what the answer to that is. I
Okay.
think right, because all of these color code to the right color. We don't have any errors or underlines anywhere. um, okay, so here's maybe a suspicion here on my part, because this relies on this action to happen. It doesn't
Oh,
really have anything in it yet, right?
okay.
So, that I'm not liking that answer really, but that's about all I can think of as to the why.
Because it's still technically empty.
Yeah, I think that might be part of it. That I'm going to tell you what, I'm not an expert on it to say this is exactly why it's happening, and I wish I was, because then I could just
Yeah.
answer it. Um, but let's talk about a couple of the things that we just did here. So, like on page 374, they have a couple paragraphs of text. I'm going to kind of read sort of through them, not verbatim, but really close. And it says, "Why does the current game, the one up here, have an exclamation at the end?" Okay, so it says, "For a brief moment between the app launch and the beginning of the first round, current game does not have a value." Right. This is a concept you're going to learn about in the next unit. And this is something I talk about, like when I teach a C# class, I often talk about this because we get that same issues. Like for example, you set up like a string variable for a username and you don't put anything in it, not even a blank string. And until you populate that, I mean, the debugging engine just really doesn't like it. So basically, we're putting it there to suppress errors, is really what it is, right? So it says, for now, know that the exclamation mark means that it's okay for this property not to have a value for a short period. Okay. Says, now that you've started a new round, you need to update the interface to reflect the new game. And it says, create a separate method called update UI. So let's do that. So let's do that here. So I'm going to say func. We'll start with it lowercase. Update UI, parentheses, curly brackets, right? And basically what this function is going to do, it's going to handle the interface updates, and then we'll call it at the end of new round. So in other words, we're going to, here at the bottom of new round, call it right away. And let's not forget to do that, because otherwise it's not going to operate. Let's trigger it to operate. Right. So inside this method, there's two pieces of the interface that you can update with the code you've written thus far: the score label and the image view, both, right? So let's come down here and do the update then. So we're going to say score label, the score label text. So the score label text will be set to wins. And we're going to say colon. And we're do our string interpolation here and just say total wins. And then I suppose we probably want to show the losses. Okay. Not that we will ever lose. Positive here. And that will be obviously total losses that we created up above. Okay, so that's part one. So we're going to update it, and whatever, if we win, it'll keep track of it, show it here, show us our wins and losses, basically. Next piece would be to change the image. So this is kind of a new thing for us here. So we're going to say the tree image view dot image. So the image that goes inside the image view is going to be changed, and we're going to call it UI image, and the version that we want named. I think that's all we need. I don't know if we need all this extra stuff here, but you know what? That's okay. That can be deleted. And yeah, I'm trying to think of like what the best approach is here. And I'm looking at what the author did, and he's just saying tree, and then he's going to string interpolate which image. So if you can kind of just do what we call here really quick. If you look at our assets, it's called tree 0, tree 1, tree 2, etc. Right? So it's the word tree, a space, and then a number. So what I'm saying then basically is here, so we have tree, a space, and then a number, and we will extract that number by pulling it from current game dot incorrect moves remaining. So like whatever calculated value we have, right? And so in other words, the tree is going to change which image, so we might have the tree with 1 apple or 2 apples or 5 apples, and that will represent basically how many moves we have left, right? All right, so all right, let's try running it now because they're telling us to build and run. Let's see what this does at this point. I think mostly is to make sure it doesn't crash, right? And it says the score label and the image view should update to reflect the beginning of a new round. So notice we have all the apples on the tree now, right? Why do we have all 7? Because that's how many moves we have remaining. So instead of loading tree 0 with no apples, it's loading tree 6 with 7 apples. And it's showing us our wins and losses, right? And the keyboard still does nothing. All right, let's go ahead and stop it at this point, and we're going to move on to the next page. So now we're moving on to page 376, which is part 3 of the apple pie build. All right. At this point, we're going to work on updating the game state. So in other words, the interface is looking okay. We got our wins and losses up there. We got a mechanism in place to update the user interface whenever we start a new round. And we do have this down here at the very bottom. So this is what we're kind of going to look at next, which is we have when a letter button is pressed right now, it just disables the button. Okay, that's great, I guess. But whenever the button is clicked, it says here, you should read the button's title, determine if the letter is in the word the player is trying to guess. So, all right, so we got to like do those mechanisms. And we're going to begin by basically reading the title from the button's configuration property. So in other words, the letter Q button, if you look at the title of it, it's Q, right? So we're going to read that property in order to, react to the letter Q, right? Not all buttons have configurations and titles, so you need to add exclamation points to tell the Swift compiler your button does not have a configuration that has a title. You'll learn more about the exclamation mark in the next unit. You should lowercase the letter because it's much easier to compare everything in lowercase and then convert it from a string to a character. So those are all the maneuvers that we're about to do here. So we're going to still leave the sender is enabled false. That's going to stay in place. But now we're going to set a couple of constants. So the first one is the thing we're going to call letter string. And basically, that's going to look at the sender, what the user interface is sending to us. And we're going to pull in the configuration, exclamation point, right, dot title, and exclamation point there too. Why? Once again, just in case that information isn't there, we don't want the application to stop working. Now, once again, I think what's interesting that this stuff isn't highlighting or color coding. You noticing that, right? We were having that issue before. Now,
Yeah.
if I did remove this stuff, I'm wondering if it will throw an error. I'm kind of waiting for the compiler to just say something, but okay, there you go. So value the optional type must be unwrapped to refer the member title wrap base. Okay, so this is the concept, by the way, that we're going to learn in the next unit. This like wrapping and unwrapping of stuff, right? So I can hit the fix button. Let's see if it fixed it. Oh, I put in a question mark, right? All right, I'm going to command Z that. That's not what we want. We're going to follow what the book says, which is exclamation point, same title. That's just to protect ourselves. Now, Interestingly, the question mark is what we use like when we code in C sharp, which is Microsoft's version of the C language. We use the question mark if we're not putting a value in something. And I think it's interesting that they have both the question mark and the exclamation point here available. I wonder what the thinking is on that. And
Is that some like leftover Objective-C stuff?
it sort of is, but they call this unwrapping, meaning they're kind of protecting it, and they only unwrap it basically when it's safe. I don't know how else to really put it. When we do the formal study on how that works, which will be in the next unit, I think we'll get a little bit more clarity, and hopefully that helps to reinforce my knowledge on this too. Okay, so with this next thing, we're gonna. Okay, so the one is set to pull the string from the letter. This one is going to indicate the letter itself, so that we're pulling up the character piece here, and they want us to use the. I'm not sure which one. Let's just use the plain character. We'll just type this in manually. And they want letter. They want us to grab that letter string and lowercase it. So lowercase like that. Curious to see what this error is here, or if it will disappear. Okay, there it went. All right. This is what we should be updated to. It says now that we've got the letter that the player guessed, what should you do with it? The game manages how many more times or how many more moves are remaining, but it doesn't know which letters have been selected during the round. Add a collection of characters to game, which is our struct, that keeps track of the selected letters named guessed letters. Then add a method in game that receives the character, adds it to the collection, updates the incorrect moves remaining if necessary. And then by adding the guessed letters property, you'll need to update the initialization for the current game. Boy, that was a mouthful. So we're going to go back to our struct now. So if you have that open, and I have it open up here, we're going to add first another property. So let's do this. We're going to add a variable called guessed. So, and this will be basically an array of characters. So we're going to grab each character that's guessed separately and then throw it in this array. And then we can programmatically check this array to see if, oh, they already typed the letter T, for example. All right. Now we're going to move on to a function here. Now we did talk about this really briefly, but you guys might not recall it. But we talked about some words. One is immutable and mutable, right? Like immutable in programming basically means you can't change it. A constant is immutable, right? And there's other things that are immutable too, but a constant is a good example. But we can also create functions that are allowed to be mutating. In other words, can allow things to change within a structure with the use of a function. And so in order for that to happen, we do have to say mutating as a keyword before it and then say func, right? And we're going to have this function called player guessed. And we're going to set up a variable inside here called letter that will hold a character. Right, now we haven't talked about this as a data type much because generally we think of like ints, doubles, and strings, right? But the reality is a string is really a collection of characters, and the character is an individual data type. And we don't want here to keep track of multiple characters, but single characters. That's why we do that. Curly brackets. All right. First thing we're going to do is we're going to take the guessed letters, and every time a player makes a guess, in other words, every time they hit a button, we're going to trigger this function, and we are going to append a letter to the guessed letter. So it's going to add to the array that we put above. So I click the letter T, it stores it in the array of characters, so we know it's off the table. Right. The next thing that we have to do is we have to check if the word that we selected contains the letter that we just typed. All right, and once again, we're going to throw in the exclamation point here, and I want you to think about what this is doing. If this is an unwrap, you know, what if it doesn't work, right? You know, we've got to have a stipulation. So I'm not sure exactly why they put it in front. But if the word, oh, wait, look, boy, I'm really being dumb about this. What happens when you put an exclamation point in front of something? It's not unwrapped.
It makes it false.
Yeah, so it's saying if the word doesn't contain is really what it's saying. It's not word contains. Okay. Duh, holy cow. More coffee, please. Excuse me.
Bless you.
Thank you. So if the word doesn't contain the letter, what are we going to do? Well, we're going to change the incorrect moves remaining, and we're going to minus equals 1. So we're reducing that value. So now you have one less move remaining. So if the letter's not in the word, subtract the remaining moves. All right, so that's our work that's done in the struct. So we'll leave that alone. That's all we need to do there. We're going to go back to our view controller now, and we're going to make a couple little tweaks now to the new round method up here to begin with. And I'm noticing here, I have something broken, and why? Okay, so because I changed the struct, right, and added a new property, well, that property is missing here, right? Because before, and we just had these two, word and incorrect moves remaining. Now over here, I have, I have those two, but I'm missing the other piece. So we have to add that other piece, basically. So I'm going to put in a comma, and then we're going to add, what was the thing we added? Guest letters. And we don't have a specific character to put in here. We don't know what it's going to be, but it's going to be basically a blank array ready to receive a character, if you see what I mean. So, right, so we do a new round, we clear out the array. If there were any things in there, well, they're gone. So this is just a way to create a blank one. That's the only change we need to make there. But now we need to go down to the IV action func here, letter button pressed, and make a couple of tweaks to this. The first line stays in place. Second line, well, that gets a little bit of a tweak. And so here, where it says letter string sender.configuration title, we are going to remove configuration. We're going to remove, for now, the exclamation point, and we're going to put in this for thing, and the user interface control state that we want to trigger is called .normal, right? What's normal? I'm not really sure. Probably not me, right? If I was normal, I probably wouldn't learn how to code. You still have to put the exclamation point at the end just in case it might be lacking that value. So this is the tweak now. With the next line, we're going to leave that one alone, it looks like, but we're going to add another directive here. So every time they press the button, what else is going to happen? We're going to look at the current game and what the player guessed. What letter did they guess? Well, I don't know, the letter. That's what they guessed. Where is that coming from? Well, that's coming from here. Right? Which letter did they guess? Well, that letter. And then after they guess, well, then we're going to update the user interface again. So we're going to call our update UI function. This is a really common little approach to GUI programming, you guys, right? So like you're writing the code for the interface, and you do something on the screen with the interface, and you want something to happen, but you also have to update the interface so that it's at the correct current state. And that's kind of why we put it here. All right. At this point, we're ready to build and run again. So go ahead and hit the button. The directive here says build and run the app. As you press each button, the character gets added to the list of letters the players has guessed, right? And incorrect moves remaining decreases by 1 for each letter. Okay, now I am getting an error here, right? And I want you to see here, it says fatal error unexpectedly found nil while unwrapping an optional value, right? And did you guys get the same thing first?
I did, yeah.
Okay, good. All right. And we need to figure out why this is happening. And let me see if it has a fix, All right, it doesn't have a fix, right? It doesn't suggest any fixes here. All right, I'm going to see if that's normal and expected, and it's not. So what we need to do then is we need to figure out where that thing should go. And I'm thinking right now, I'm going to try it without. Right, and you can see it doesn't like that, so that's not going to be the answer.
Does that one have a quick fix?
The value of optional type string must be unwrapped to refer to the member lowercase of the wrap style based string, chain optional, yada, yada, yada. Chain the optional question mark to the access member lowercase. Okay, so they're saying you can add a question mark after lowercase, I'm not sure. Or force unwrap using exclamation point. That might be the fix to abort execution if the optional value contains no. I'm going to click fix. Okay, well, you know what? Let's stop the program from running. Let's see if that fixes it. I have my doubts here, right? Looking letter P. Oh, it crashed again in the same spot. Oh, and okay. So interesting, because it added the exclamation here. You guys see where it added it?
Yeah.
Yeah. And it's saying that letter string is nil. It says the center dot title for normal. All right, let's put this back in. I'm going to stop it running again. Boy, it sure doesn't like that. All right. Do not force unwrap value of a non-optional type. Remove exclamation. Didn't you just put it in for me? So I must have accidentally deleted that. Let's try that again. It would be silly if it just works now. Right? No, it's still failing. All right. How about this? This is a great time to take a break because it'll give us a chance to figure it out. But I'm going to pause the video. Let's do like a 5-minute break. And then we can come back. We'll work on troubleshooting this together.
Okay.
All right.
So I'm pausing the video. See you in about 5.